Welcome to another math problem of the week. Triangle, ratio of lengths, maximum possible area of ABC. Let's talk about it. So for this question, we have a triangle ABC where the length of AB is 5, that's certain. But the length of AC to BC is of the ratio 12 to 13. We are asked to find the maximum possible area of triangle ABC. The options are A, 30, B, 60, C, 78, and D, 86. What do you think?
Pause the video now if you wish to solve it. Keep watching the video once ready.
There are various ways to solve this question. It can be solved by using trigonometry, and the method that I'm going to present is via the Heron's formula. So the Heron's formula said the area of triangle ABC will be equal to the square root of S, S minus A, S minus B, and S minus C, where S is equal to half of the perimeter. And each of the ABC is the length of the triangle ABC. So in our case, we will let AC to be 12K and BC therefore will equal to 13K. So S will equal to 5 plus 12K plus 13K over 2. And I call this area as J. In order to find the maximum possible of J, we will consider J squared so that I can get rid of the square root. Now, if J squared is maximum, and so for J, so now we just focus on what is the maximum of J squared first. So it will be equal to S, that is equal to 25K plus 5 over 2. And S minus A, where A is equal to BC, that is A, and AC is equal to B, and AB is equal to C. Alright? So S minus A will be equal to 5 minus K over 2. S minus B, 5 plus K over 2. And finally, S minus C will be 25K minus 5 over 2. So we have 2, 2, 2, 2, that is 1 over 16. This is 25 plus 5, 25 minus 5. Each of these has a 5 as a factor. We can take it out and it will be equal to 5 squared. This is 5K plus 1 and 5K minus 1. It will become A plus B, A minus B, so it will be A squared minus B squared, and therefore it is 25K squared minus 1. And for this will be 5 minus K and 5 plus K, and therefore it's 25 minus K using the same argument. So this will be equal to 5 over 4 squared. After expanding, this expression is actually a quadratic equation in K squared, which means that this will give us negative 25K to the power 4, and this is 25 squared, that is 625 plus 1, so that's 626K squared and negative 25. If you enjoyed this video, please like, comment and subscribe. Now we can actually complete the square here, so this will be equals to 5K squared minus half of it will be 313. So it's 313 over 5 and square. And this is negative. Okay. So when you expand this, we'll have this term 25K to the power 4. And next 2AB will equal to 626K squared. And we left with 313 over 5 squared. So it is 313 over 5 squared here. And minus this 25. So now J squared is equal to this expression, and therefore it must be less than or equal to 5 over 4 squared and 313 over 5 square minus 25. And the equality holds if and only if 5k squared minus 313 over 5 equals to 0. This expression looks complicated, but after we do the calculation, this is a very nice answer. This is 6084, and it is actually equals to 78 square. Amazing. Right, so what we have so far is j squared is less than or equal to 78 square. So we can say that, therefore, j will be less than or equal to 78. And we need to verify that whether 78 is the maximum value of j. The equality holds if and only if, and only if this equals to 0. It means that k squared equals to 313 over 25. And which means that k will be equal to square root of 313 over 5. That is a positive value for k. And this means that 75 is reachable. And now we conclude that the maximum possible value of j will be equal to 78. And therefore the answer for this question is C. I'm happy to receive various methods to get the solution. For now, let's look at other people's solution. That's all for today's lesson. I'll see you again next Tuesday. Bye bye.